Alright, let's take a look at this question. This one here is probably the hardest type of question that you're going to have to answer. It's called a limiting reactant. Up until now, you've been told which one is in excess, and by definition that means there's more than enough, which means the other one is limiting. It limits the reaction. The reaction will go until it runs out. So it's what controls the reaction, if you will. And in this type of question, which is a more practical question, we have a certain mass of each thing, but we don't actually know which one runs out first. And so we're going to have to figure that out. So let's take a look. Get my calculator ready. I've filled in all of the given information: 25 grams of aluminum hydroxide, 125 grams of acetic acid. If you don't know acetic acid, you could Google it, but it's just acetate with an H, acetic acid. And make sure that when we read it, we read it properly. So it says react acetic acid with aluminum hydroxide to form water and aluminum acetate. We could put in solubilities if you want, but that's not required for us to answer this. Alright, so now we have to do some math. So let's figure this out. I want to know the moles of each. So that's the first thing I'm going to find when in doubt. Find the mole. Mass divided by molar mass. It's 125 point nothing divided by 60.052 equals more than 1. I have more than 1 mole. I have 2 actually. Well, that makes sense. 60 times 2 is 120. A little over 2. 2.08152934. 2.08152934. Bye. This one here is moles equals mass divided by molar mass, which equals 275 divided by 78.004, which equals 275 divided by 78.004 equals 3.52546. 023. I'm just going to put 3.5255 in there for now. Okay, so I've calculated some things out. Now the question is, how much is used up during? And before we used to say, well, this is excess, so all is used up. Well, in this case, I don't know, because I have a different ratio. What I would suggest that you do is kind of think about this and see which one do you think is going to run out first. If I had, let's say, 1 mole of this, I don't, I have 3.5, but let's assume I had 1 mole, I would need 3 moles of that. Well, I don't have even 3 moles here, and I have more than 1 mole there, which means this one's probably going to run out first. If I had 3.5, I would need, let's do the math, 3 over 1, right, 3.5, times 3 over 1 would be 10.5 moles. I don't have 10.5 moles. So I'm just doing a quick assessment. If I used all of this, 3.5 times 3 over 1, I would need 10.5. I have 2. Obviously, that's not going to work. The reaction's going to stop when I run out of the 2 that I have before I ever get to the 10.5. So what does that tell me? It tells me that all of this is used up. 2.8152934. All of that is used up, and the reaction stops when it gets to 0. Limiting. That limits the reaction. That means there should be some left over here. This should be excess. That's what we're saying. So let's see. If I use all of that times reaction box I'm going to is 1 over the box I'm coming from is 3, 1/3. Alright, let's do this. 2.08152934 times 1 divided by 3 gives me 0.6934 moles. Well, if I had 3.5255 and I used up 0.69384 during the reaction, I'm left with 2.83166 moles afterwards. Okay, and this proves it. How do I prove which one's limiting? How do I find out which reactant one's first? I show it here in my moles after. The one that goes to 0 is limiting. That's the number that we use. The one that has stuff left over, by definition, that's excess. Okay, the key here is not to get tricked by the numbers. In this case, the number of grams here is way bigger than that. You might think that's always the case. It's not always the case. If this weighed, I don't know, 400 as a molar mass, then this would be less than a mole. This would be limiting, even though I had 400 grams to 125, okay, or 275 to 125, because each mole weighs so much more. So it's not the mass. Find the moles and just do a quick calculation. Do a quick mole ratio calculation. It'll tell you right away which one's limiting. All right. That being said, I know this is the value I use, so I want to go from here to there. I could use this number, but I calculated it. I had to times 1 over 3, and if I screwed up somewhere and I use this number to do the rest, well, that's going to be a problem. Here I've only done one calculation. I found the moles and I brought it down. Here I did 2 calculations. I found the moles and then I multiplied again. You want to limit your error, so always go from the limiting reactant box, if you will. Times, so from the box I'm going to is 1. Box I'm coming from is 1/3. So it's 1/3. I've already done that math, so I know that it's 0.69384 moles. If I started with 0 and I made 0.69, that means I must end up with 0.69384. And if I want to know what that weighs, it's simple. 3. The moles equals the mass times the molar mass, which equals 0.69384 moles times 204.12 grams in every mole. 0.69384 times 204.11 is 141.619 grams to significant digits, because this is 3 here and 3 here. 141 grams, which is what the answer is. So I know that I've done it right. So these are no harder than anything you've done, except you have to recognize this step. I have to figure out which one is limiting and which one is in excess so that I can go ahead and calculate.